Okay, in this video we're going to continue our discussion on dimensional analysis. In our last problem we just found the units of this quantity A, which turns out to be acceleration, which are derived unit. Now we want to look at how units can help us determine whether or not an equation is correct or if we've made an algebraic mistake. So to do that, we do what is called dimensional analysis. And we're going to use the units of algebra to help us check our math and determine if a formula is correct or not. We can also use this as a way to interpret what an equation may be telling us. The main thing to remember is that units are your friends. I like to say they're my children, and if students don't use the units right, then they're abusing my children, and I'm going to punish them for abusing my children, okay? Students often think of units as some sort of hassle or something that they're being made to put down. This is a very bad way to look at it, because students lose a lot of points because they make algebra and other mistakes. Points they wouldn't lose if they checked their units. Units should be checked on each and every line of your work. That's how I find a mistake. When I find that something doesn't work out, I start going up the lines to look for units. When I'm doing work and a mistake of mine professionally could actually cost somebody's life or make us lose a lot of money, I check my work to ensure that I'm not doing things wrong by checking the units on each and every line. I don't just stick in units on the last part of the answer. If you do that, you're defeating the whole purpose of this thing. So, you should check the units on every line of your work. That's how I check them, and it's how I grade them. This is how I find your mistakes and give you partial credit. It'd be better if you found them and got full credit. Rule number 1. The units on both sides of an algebraic equation must be the same. You cannot say 3 apples equal 4 oranges. You can't say 3 apples equal 3 oranges, unless you had some conversion factor that converts the apples to oranges or the oranges to apples. If you've got something on one side that you're doing, then it should have the same units as the other side. As an example, let me show you this one. X is the distance in meters. Time is set in t and is in seconds. And v, later on, in this case, we're going to say is speed, and its units must be in meters per second. And we've written down this formula. Did we write down a right formula, or did we make a mistake? Well, let's at least check to make sure it meets the criteria that the units on this side here have to match the units on that side of the equal sign. Equal is a statement of honesty. It's not a statement that is sort of like that. It says specifically this is the same as that. And if it's not, it's wrong. So to check that, we look at the units over here, and we look at the units on the right hand side. And I know the units here, I'm told from physics, or I know that they're supposed to be meters per second. And if you would, I'm going to put a question, because that's really the thing, is are they equal? Over here on X, the units are meters, and the units of time are seconds. So this is meters divided by seconds. This is meters times seconds. They are not equal. This equation can't be right. Now, that doesn't mean that if the units work out that you're guaranteed the equation is right, but if the units don't work out, you're guaranteed it's wrong. All right, so the equation could have the same units and not be correct, but if the equation doesn't have the same units, it's definitely wrong and goes out the window. Also, if I look at this, it might suggest how I might want to fix this. This is meters per second. What I really need to do is divide by time, not to multiply. So a possible equation would be this equation. At least that equation has the right units. Okay? So units are your friends. Make sure the units on both sides of each line of your algebraic equation are the same. If they're not, you've messed up the algebra on that line. Don't go writing 10 more lines that you'll have to erase. Fix that line right there when it happens. Rule number 2. The units of each term of an algebraic equation must be the same. If I'm going to count up the number of apples, and I add 3 apples, then I'm going to add up some more. Each term I'm adding have to be apples. So when I'm looking at something here, x naught, x, t, v naught, and a, x and x naught have the units of meters. It's said that t has the units of seconds, v naught has the units of meters per second, and a has the units of meters per second squared, and I'm given this equation. And I want to see if this equation might be right. Units of x has to equal the units of x naught plus the units of v naught plus the units of t, should say times the units of t, so these two are multiplied according to that formula, plus the units of a times the units of t cubed. The units of this are meters. The units of that are meters. The units of this are meters per second times second. Well, when I look at that second cancels that second. The units are meters. Same as this, same as that. So if I got 3 apples and I add 2 apples, I could have 5 apples. Notice this is not 2m. These are units. They have to have the same units. These are not m is like m being a variable, and so m plus m is 2m. These are units. Then plus a is meters per second squared, and then I'm going to multiply that by second cubed. Well, the second squared gets canceled, but there's a second left over. So this term is meters times second. This term is a problem. Can't be right. Now, if that had been a times t squared, it would have had the right unit. So one thing it tells me is that this can't be cubed. This has got to be like to the second power. Now, it turns out the correct formula, we'll find out in a later chapter, happens to be this formula. So it should have been a squared. But notice the 1/2. Because the 1/2 had no units, you wouldn't catch that error. You would catch this error because the units. So again, even though the units might be wrong, if I left out the 1/2, and they might work out, that doesn't mean the equation's right. But if the units don't work out, it definitely means the equation is wrong. All right, so not dimensionally correct. So no need to go and plug numbers in, because you're not going to get credit. And it tells me that you're not even paying attention to your work. You're just planning to kill somebody and not worry about it. All right? Serious technical work. We have to be serious about what we're doing. All right? This term cannot be right. These two terms at least match up. So, units of each term must be the same. What if you have 1 in hours and 1 in seconds? Then you got to convert them all to the same thing. All right. Arguments of all trigonometric and exponential functions must be unitless. Now, why is that? So if you take the cosine of something, cosine of 3 seconds, can't be right. I don't know what you did in the math to get this thing down to here, but you must have messed up somewhere. You can end up with an angle or whatever that's in seconds. I don't care if you had something like this. You had acceleration times time, and that happened to be meters per second squared, and then you multiplied by a second. then this thing would have units. That's not possible. Can't happen. A unit must be unitless. Whatever you do to find that thing, it's got to be unitless before you take the cosine. How do I know this? Well, one of the things they don't teach you until later courses in mathematics is how calculators, which don't know anything about geometry and triangles, manage to calculate the cosine function. Well, they don't do it based on adjacent over the hypotenuse or any of the stuff that we're going to talk about in our review of trig in one of the later videos. What they do is they do it in terms of what is called an infinite series. So if you have the cosine of an angle, they take 1 minus that angle squared over 2 factorial, where this is 2 times 1, for those who forgot what a factorial is, plus the angle to the 4th power divided by 4 factorial, which is 4 times 3 times 2 times 1, and so forth. Notice each one of these terms has an even power, and this term could be written as x to the 0 over 0 factorial. Because each one has an even term, the cosine function is said to be an even function, back in pre-calculus classes or in Algebra 2, depending on your school. Well, the problem is, since these are summed, these have to have the same units, but they don't have the same power. So let's say that x had the units of, say, seconds. Then the cosine of x would have the units of no unit. That would be 1. And then it would be minus, and then this term would have the units of second squared. And then this unit would be second to the 4th. And then this one would have the units of second to the 6th. And remember, I'm not really subtracting, I'm just looking at the terms. So this have nothing, this would be second squared, this would be second. This cannot be, it violates rule 2. That means that that formula says the only way to deal with the cosine is if the units are none. Because if there's no units, this will be no units. No units squared is still no units. No units to the 4th is still no units. And there'll be no units. Any argument of a trig function or an exponential must be unitless because it is related to one of these type of series. Now this brings up an interesting point, and that is the definition of angles. The degree, it turns out, is not an appropriate thing for doing these type of definitions. And that's because it's not unitless. But there is a unit that is unitless for an angle. If you take this length and divide by that radius in a circle, not a very good circle, you can divide that as an angle, and that is called the radian. So the definition of a radian is for a given angle, it is the length of the arc divided by the radius. This is in meters, this is in meters, and meters divided by meters cancels and is unitless. So radians are, what does the calculator do? When you put in the cosine of 45 degrees, it converts it first to radians inside, and then it does this. It knows you can't be using degrees, and so it fixes that problem itself. All right, we'll continue this in our next video.